Hi, this video lecture is made only for the purpose of chemical engineering students. The reason being, probably you might have understood by this time, I already uploaded some two to three videos on the vector integration. There we have the surface integral and the volume integral. And the surface integral, for evaluation of surface integral, we need to evaluate a double integration. For volume integral, we need to evaluate a triple integration. The, the double integration and the triple integration, uh, you didn't learn in either in the first semester or in the second semester. You don't have these two topics in your curriculum. Therefore, probably students may feel a bit difficult in understanding the vector integration. Therefore, especially for the benefit of chemical engineering students, I'm making this small video for giving a idea on double and triple integration. So first I will give you idea on double integration. So this So in your intermediate you learned single integral. So only the key points I'll mention, not in detail, which is enough for you to follow the topics of vector integration. Integral a to b fx dx. This you learned how to evaluate this. So this fx is an integrand in the variable x. That x is taking all the values in between a and b in the interval a and b. Whenever you come across the integration of integration of a function involving two variables x and y, how to do the integration with respect to both the variables. So it is somehow represented like this: double integral f of xy dx dy. Now, how to evaluate this double integral? As in the case of a single integral, the interval, the variable x is taking all the points in between a and b. Similarly, here also the x and y will take all the points in some region in the xy plane. Let us call that region R as the xy plane. So x and y are taking all the points in the region R, all the points in the region R. So we need to evaluate double integral f of xy dx dy. As a, I would like to give you a general idea what actually this double integral f of xy dx dy means. I'll simply extend that idea from the single integration concept of single integration. Of course, I'm not going to define what is a definite integral a to b fx dx and all those things. So making a simpler one, if I integrate integral a to b, say x square dx, or otherwise I'll say integral 1 to 2 x square dx. If I want to evaluate that, you know that the integral value is this x cube by 3. After substituting the limits 1 and 2, you will get a 7 by 3. 2 cube minus 1 cube, 7 by 3. What actually it means? You have the curve y is equal to x square. Y is equal to x square is a parabola, you know. This is the curve y is equal to x square. Between x is taking the values between 1 and 2. So this is your fx. So in between 1 and 2, x is taking all the values in between 1 and 2. If I take some x naught, you can find out fx naught. If I take one another x1 in between 1 and 2, you will fx1 is this. In this figure, you can observe fx1 is this line segment. Fx3 is line segment. Fx4 is line segment. So if uh, you are simply adding all these line segments, and ultimately whatever that value is, mm, comes up to 7 by 3. So in the similar way, in double integration also, at each and every point of xy, you uh, find the value of the function f of xy at each and every point, f x naught y naught, f of x1 y1, f of x2 y2, f of x3 y3, and sum up all the values. Whatever result you will get, that is the double integral over f of xy dx dy. As a nutshell, I am giving that idea. Now the point is, in between x and in between in the region R, we will have infinite number of points, and finding out that f of xy at each and every point and adding all those things is a very difficult task. Then further, how to evaluate the double integral f of xy dx dy, we learn now. Okay, this is the region what you have. Now, the idea is this. Suppose given x is given to you. For example, say say xp is given to you. And whenever if I give you a value of x, then if I draw the line x is equal to xp, that is cutting this region at 2 points. Such a region I have taken, that such a region we call it as a simple region. I am evaluating the double integral over a simple region. Okay. In if I give x is equal to xp, this line is cutting this region at 2 points. So this is one point and this is another point. So if I at this point the value of the function at this point the value of y is given by some f of xp, and at this point the value of y is given by y2 y1 and it is y2 f of xp. Now you integrate this in between, that f of x y1 and y2, between y1 and y2. This y is given f of x and here it is f of x. And change that p between these two lines. Suppose say this region is in between these two lines a and b. So that xp varies in between a and b. So integral a to b, and this is f of f1 of x and this is f2 of x, that f of xy, now dy dx. The other way also we can find out the region. Suppose this is the region R. I can consider this region as a region between these two lines, y is equal to c and y is equal to d. And if I give an x is given to you for a given x, this x touches the uh, boundary at this point, and here the value of x is given by some f1 of y is given to f1 of y, and the value of x is given as f2 of y. So x varies between f1 to f2, f1 of y to f2 of y, and this y now varies between c and d, integral c to d, and the function f of xy dx dy. So this is uh, evaluation of double integral over this region E R. So we can evaluate the double integral over a simple region R in two ways. One is, first you are doing, if x is given to you, you are doing the integration with respect to y, and next with respect to x. Or for a given y, you are integrating with respect to x, and that y is varying between two lines. So the order is first with respect to x, next with respect to y, or first with respect to y and next with respect to x. If I do the first with respect to y, I am doing the integration whenever an x is given to you. Whenever x is given for such an x, find the limits for y. So these will be functions of x. When they are functions of x, they are the limits for y. Whenever they are limits functions of y, they are limits for x. And the x limits will be in between two constants. So this is how we will find out the double integral. For understanding of this concept, I'll solve a problem. Suppose if you have some Uh, say a simple one I'll take. Take a triangle formed by the lines y is equal to 0, x is equal to 0, and x plus y is equal to 3. This line. So this is the triangular region. This is the region R. In this region R, evaluate say x square y some dx dy. Whether you write dy dx or dx dy, that depends on the limits what you write here. If you don't write the if you don't write the limits, you can write anyway dx dy or dy dx. The order what you are following will be understood by the limits. Okay. Now, in this region, suppose an x is given to you. Here, what is the value of x? And what is the value of y? Y is 0 here. And what is the value of y here? The value of y when x is given can be understood by that y is equal to 3 minus x. So, y varies from 0 to 3 minus x. This is for a given x. From where to where this x may take values here or here or here. So x will take the values from x is equal to 0 to this point. What is this point? This is 3, 0. Here the value of x is 3. So from x varies from 0 to 3, x square y. And order you need to write here with respect to what variable you are doing the integration. You are doing the integration first with respect to y. These are the functions of x means they are the limits for y and next x. While doing the integration with respect to y, treat x as constant because for a given x, that means x is fixed and you are taking the limits for y. What is the integral for x square y with respect to y? X square x square is constant. Integral y is y square by 2. In place of y square, if I substitute the limits 3 minus x whole square by 2 minus 0 square by 2. So this is after substituting the limits. Now integral 0 to 3 x square into 3 minus x whole square by 2. This is an integration of a single variable. You can do that integration, evaluate it. This gives you the value of that integral. Or somebody else may do the same integration in this way. Say given y, suppose y is given to you. Whenever y is given to you in this region R, what is the least value for x for a given y? Here the value of x is 0. What is the value of x here? The value of x here is 3 minus y. So x varies from 0 to 3 minus y. And where y varies from here 0 to 3. X square y. What is the order? First I am doing the integration with respect to x and next with respect to y. So this is 0 to 3. Y into integral x is x cube by 3. That is 3 minus y whole cube by 3 dy. So whether I integrate this, whatever value I get here also, I'll get the same value. So both are same. This is how we evaluate a double integral. In any manner we can do it. For example, if I want to evaluate the another as an example, this is y square is equal to 4ax and x square is equal to 4ay are the two parabolas. Y square is equal to 4ax, that is this parabola, not this one. This is y square is equal to 4ax and this is x square is equal to 4ay. These two are the parabolas. Uh, if I want to integrate this, how do you integrate? So double integral. Now for a given x is given in this region, this is my region. If you observe that region, in this region for a given x, what is the value of y? Here the value of y is x square by 4a. And what is the value of x here? What is the value of y here? Y value is root 4ax. And from where to where this x is varying? X is varying from 0 to this point. This point is a comma a. So 0 to a. Whatever integrand, suppose if I give xy and here dy dx is the order. So it is also same as the integration part I am not doing. So first of all, you need to do that integration with respect to y. Whenever you are doing the integration with respect to y, x is constant, therefore integral for x is x into y square by 2. Substitute the limits, everything comes in terms of x, and next with respect to a. If for a given y is given to you, what is the value of y here? For a given y, what is the value of x here? X is y square by 4a, and what here the value of x is root 4ay, 0 to a. This is xy dx dy. If you integrate either in this way or in this way, you will get the same integral. Suppose this is the circle what is given to you. Say x square plus y square minus 2x is equal to 0. That means 1, 0 is the center and it is passing through the origin. 1, 0 is the center. And I want to do the integration over this region R. Integral, some integrand is given to you, x square plus y square dx dy. What are the limits? Now, this is my x-axis and this is y-axis. If I integrate this with if I for a given x, what is the value of x here? The value of x here and here we need to find out. So you need to find the value of x here. From this equation, what is your x? You simply consider it as a quadratic in x. X value is minus b plus or minus root over b square is minus 4ac by 2a. So here the value of x is 1 plus or minus 1 minus y square. So here the value of x is 1 minus root 1 minus y square to 1 plus root 1 minus y square. Here 1 minus root 1 plus y square, it is 1 plus root 1 minus y square. And this x is varying from here to here. What is the value of x here? X is 0, this is 1, and here it is 2. What are the limits for x? X limits are 0 to 2. So these x limits are this, and y limits are this. This is for a given y. Y is, if a y is given, if y is given, the value of x is this, the value of x is here 1 minus root over 1 minus y square to 1 plus root 1 minus y square. 1 minus root 1 minus y square. Y varies from here, the value of y is this is minus 1 to 1, not 0 to 2, minus 1 to 1. In this way, we need to find the limits for x and y. Sometimes suppose if I ask you to evaluate double integral xy dx dy in the first quadrant of the circle, x square plus y square is equal to a square. So my region of integration is this. So in this region, if I want to do the integration first with respect to x, that means y is given to you. That means I have taken y in this way. For a given y, this is not in this portion is not in my region of integration. This is also not there. Only the first quadrant. So in this region, if for a given y, the value of x is 0 and the value of x here it is a square minus y square with a square under square root. X is equal to root a square minus y square. X is root a square minus y square. And this y varies from 0 to a. This is a is the radius, therefore it is y is equal to a. The same thing you can do it in this way also. For a given x, here the value of y is 0 and here it is root a square minus x square and x varies from 0 to a. xy dy dx. So both are same. You can do the integration in any of the fashion. I am not evaluating this here. Integral 0 to a. I will evaluate this integral only for your convenience. If I want to integrate with respect to y first, then x is constant. Integral y is y square by 2. If I substitute the limits, a square minus x square by 2 dx. So if I integrate it, 1 by 2 comes out a square x. Integral x is x square by 2. If I substitute the limits a square by 2 minus x cube X cube integral is x power 4 by 4. If I substitute the limits, it is a power 4 by 4. So I can take a power 4 common, a power 4 by 2 into half minus 1 by 4, that is 1/4. Ultimately, this is a power 4 by 8. Even if you integrate this, even this also you will get as a power 4 by 8. You can do the integration in any way. So one more concept I'll give you for the two variables is called evaluation of double integrals in polar coordinates. I'll consider the same example. Let us evaluate double integral over that region or some xy dx dy, but using polar coordinates. So that means you are changing the coordinates from Cartesian to polar coordinates. You just remember that because this is simply an informative lecture, I am not going to give you everything here. This dx dy will become r dr d theta. Once you convert that in your intermediate, you learned integral say 0 to a root a square minus x square is if you want to evaluate this integral, there you will do it by a substitution like x is equal to a sine theta. Then for dx, you simply don't write d theta, but you will write a cos theta d theta. This a cos theta you will get. Similar way, here how it comes and all those things I am not discussing there. When a dx dy will not simply convert to dr d theta because in polar coordinates you know the relation x is r cos theta and y is equal to r sin theta. This is the relationship between Cartesian coordinates and polar coordinates. So x is r cos theta and y is r sin theta. This dx dy simply do not become dr d theta, but before that there will be a factor r. Don't forget to put that r. So double integral, this x is r cos theta. Here in the integrand, wherever x is there, write r cos theta. Wherever y is there, write r sin theta. Dx dy, you write it as r dr d theta. How to take the limits for r and theta? In polar coordinates, as in Cartesian coordinates, I just explained to you for taking the limits. For if x is given, what are the limits for y? Or for y is given, what are the limits for x? That is how you find out. Now here in polar coordinates, if theta is given, theta is this. This is the angle. If theta is given, what is the minimum value of r and what is the maximum value of r? Here r value is 0. Here r value is a here in because for this circle. So minimum and maximum values for R for this problem are 0 to A. And from where the theta varies from 0 to pi by 2 because in the first quadrant we have 0 to pi. If the entire circle is given, it is 0 to A, 0 to pi by 2. Evaluate this integral as usual. This is integral 0 to pi by 2, integral 0 to A, r into r square, another r, so this is r cube, cos theta, sin theta, dr d theta. If I integrate with respect to r first, integral r cube is r power 4 by 4. If I substitute the limits a power 4 by 4, integral 0 to pi by 2, cos theta, sin theta, d theta. If I take sin theta as t, cos theta d theta is dt, it is t dt. And if I integrate that t square by 2, t square is t sin theta, sin square theta by 2. Between the limits 0 to pi by 2, sin pi by 2 is 1, sin 0 is 0. Therefore, it is a power 4 by 4 into 1 by 2, that is a power 4 by 8. In polar coordinates also, if you convert that problem into polar coordinates, this is what the answer is. Already previously I have given one problem for you to do it. X square plus y square minus 2x is equal to 0. This is 1, 0 is the center. This is it passes through the origin. If in polar coordinates, how to evaluate this? Because it is given in polar coordinates, you need to write the equation of the circle also in polar coordinates. How to convert from Cartesian to polar coordinates? X is r cos theta, y is r sin theta is the relation. So x square plus y square minus 2x is equal to 0 becomes x square plus y square is r square minus 2r cos theta equal to 0. So it is r is equal to 2 cos theta. Equation of this circle is r is equal to 2 cos theta. So this is the initial line. If I take this here any point, if I join these two, this is the angle theta and this length is r. Okay. Now I want to evaluate double integral, some integrand. Here, what is that integrand I have given to you for this problem here? X square plus y square. Some x square plus y square dx dy. So double integral x square plus y square dx dy. This is what I need to evaluate over this integral. Previously, I have given you how to find the limit. The same thing in polar coordinates. X square plus y square is r square. I said dx dy is to be replaced with r dr d theta. And now what are the limits for r and theta? So if theta is given, this is my entire region R. In this, what are the limits for R? R varies from here, it is 0. And if I take the point, this is R. If I take this point here, but maximum value is this. What is the value of R here? Equation we learned, R is equal to 2 cos theta is the equation of the circle. Here the value of R is 2 cos theta. So 0 to 2 cos theta is the are the limits for r for a given theta. From where to where the theta varies? Theta varies from 0 to pi here. This is r is equal to 0. This is 0 to pi, and after that this is 0 to 2 pi. Or because it is symmetric, I can write it as twice integral 0 to pi. Only this part and multiply by 2. So if you evaluate this twice integral 0 to pi, integral r cube is r power 4 by 4. If I substitute the limits, 2 power 4 cos power 4 theta by 4 d theta. 2 power 4 is 16, 16 by 4 is 4, 4 2 is 8, 8 times integral 0 to pi cos power 4 theta d theta. So it is twice integral 0 to pi by 2, 16 times integral 0 to pi by 2 cos power 4 theta d theta. You know the reduction formula, that is 3 by 4, 1 by 2 into pi by 2, 2 into 4 into 4, that is 16. This goes out and ultimately you will get 3 pi. This integral value is 3 pi. Whereas if I keep that in the same way in Cartesian coordinates and if I try to evaluate, here also I will get the same value, but evaluation is a bit difficult because the limits include 1 minus root 1 minus y square to plus root 1 minus y square and minus 1 to 1. Evaluation of the integral is a bit difficult. So once you have a region, if it is convenient, you evaluate in terms of Cartesian coordinates or otherwise convert them into polar coordinates and do it. So this is what the double integration. For triple integration, a detailed lecture on triple integration is uploaded in the for you. You can go through that. Uh, I think a link is uploaded given to you. From that link in the you can see my lectures on triple integration. This topic is there for all the other branches except chemical. Chemical students are also requested to go through this triple integration and this double integration first and then move to vector integration. Thereby you can understand that easily. So I hope, though this lecture is not a complete one, as a overall idea I have given, understand these things and try to solve the problems. You will come across evaluation of double integrals whenever I solve the surface integral problems and all. Then you can understand those things. In those lectures on surface integrals also, you will come across evaluation of double integrals. Those things you will understand after following this lecture. Okay, good luck.